straight line. عزيزي طالب ثانوية عامة، المهم جدا انك تعرف ان الامتحان اختيار من متعدد multi choice for multi choice. قبل ما تختار لابد انك انت تختار اجابة صحيحة ومتقنة ومتأكد 100% ان هي اجابة صحيحة. قبل ما تختار لازم تفكر، وقبل ما تفكر في حاجة إيجابية إنك أنت الاختيار ما ياخدش أكتر من 3 دقايق أتموست على الأكثر. ولازم عشان تفكر كويس لازم تفهم. فموضوعنا النهاردة لازم نفهم الإيكويجن أوف ستريت لاين والجنرال إيكويجن أوف ستريت لاين. بعد كده نقدر ندي امتحانات أو اكسرسايز على اختيار من متعدد. Welcome my dear student in our math program for second 3. Today we are taking new lesson in solid geometry. Its title, Equation of Straight Line in Space. My dear student, look at introduction about equation of straight line in space. Look at, my dear student, you learned in previous years the straight line in a plane and how to find the forms of equation of a straight line in plane, vector form, parametric or general form. In this session we learn the straight line in space and how to get equation of a straight line in space in different forms because it's much important in geometric fields. My dear student, direction vector of a straight line in space. What is the meaning of direction vector of a straight line in space? Look at this figure. We have 3 angles. Theta x, theta y, theta z are directed angles of a straight line in space. The straight line L inclined with x-axis with theta x and y-axis theta y inclined at z-axis with angle theta z. Also cosine theta x, cosine theta y, cosine theta z are directed cosine of straight line. Remember, we have theta x, theta y, theta z are called, yes, directed angle. But cosine theta x, cosine theta y, cosine theta z are called directed cosine of straight line. They are usually denoted by L, M, N. L represent cosine theta x, M cosine theta y, N cosine theta z. L, M, and N. We know that cosine theta x is cosine power 2 theta x plus cosine power 2 theta y plus cosine power 2 theta z equals 1. Therefore, L squared plus M squared plus N squared must be equals 1. The vector, unit vector Li plus Mj plus Nk is unit vector in direction of a straight line. Remember, unit vector in direction of a straight line, its symbol U vector equals Li plus Mj plus Nk. What is I? Unit vector in x-axis. J, unit vector in y-axis. K, unit vector in z-axis. And remember I, this vector, unit vector, its component 1, 0, 0. But J, 0, 1, 0. K, 0, 0, 1. Any vector parallel to the unit vector U is called direction vector of a straight line and denoted by D vector. Then we know D vector equals K multiply Li plus Mg plus Nk, or A, B, C. Remember, my dear student, A, B, and C are proportional to L, M, N, and K belongs to R. Example. If we have third, two-third, third, two-third, direction cosine of a straight line. What you mean? Cosine theta x, two-third. Cosine theta y, third. Cosine theta z, two-third. The vector, the vector k multiply cosine theta x, cosine theta y, cosine theta z. Therefore, direction vector d equals k multiply vector its component two-third, one-third, two-third. Represent direction vector of the straight line, but k not equal 0. But k equal 3, then we deduce direction vector 2, 1, 2. But k equal negative 6, therefore d vector negative 4, negative 2, negative 4. What you mean? Straight line has infinite number of parallel direction vector, each is parallel to straight line. How many straight line parallel? This is straight line, many or infinite number of straight line parallel direction vector. Example. Find direction vector of a straight line pass through the point A, negative 2, 3, 1. B, 0, 4, negative 2. My dear student, we know that the straight line pass through 2 points A and B. Then AB vector equals B minus A. Point B minus point A. This is called direction vector AB. Thus, look at solution. Direction vector AB vector equals B minus A. Therefore, we put the point B or coordinates of point B minus coordinates of point A, then direction vector 2, 1, negative 3. Now we are translate to vector form of equation of a straight line in space. My dear student, remember, we have vector form of equation, parametric form of equation of straight line, and Cartesian equation of straight line. How many equation? 3. Vector form of straight line, parametric form of straight line, Cartesian form of straight line. Now we study for vector form of equation of straight line in space. Look, my dear student, we have L straight line in space whose direction vector D vector A, B, and C. Its component A, B, and C. Pass through the point A whose position vector x1, y1, z1, and the point B, any point on a straight line whose position vector is r, x, y, z. Remember, the 2 points A and B belongs to straight line, A vector, OA vector, R vector, OB vector. Then we deduce that R vector equals A vector plus AB vector. This equation from the first secondary. R vector equals A vector plus AB vector from the vector lesson. Look at R vector, OB vector, A vector, OA vector, AB vector. Thus, we deduce that R vector equals A vector plus AB vector. But we know AB vector parallel to direction vector. Therefore, from parallelism rules, we know AB vector equals TD vector. Therefore, we deduce that R vector equals A vector plus TD vector. What is the D vector? Direction vector of a straight line. What is the A vector? The vector OA, or the point A belongs to the straight line or straight line pass through it. Vector form of a straight line, this R vector equal A vector plus TD vector. Now we are translate to important example. Look at what is the vector form of equation of a straight line pass through 2 points, or pass through 3, -1, 0, and the vector or direction vector -2, 4, 3. We know that, my dear student, in any exam, this example must be multi-choice. Choose from the correct answer. Before we choose the correct answer, we make how to form vector form of equation of straight line. What is the vector form of equation of a straight line? Excellent student. R vector equals A vector plus TD vector. What is the A vector? 3, -1, 0. Good. What is the direction vector? Yes, -2, 4, 3. What is the equation? R equals 3, -1, 0 plus T, -2, 4, 3. This is the vector form. Look at, my dear student, 3, -1, 0 represent point on straight line. Then A vector equal 3, -1, 0 and -2, 4, 3 represent direction vector of straight line. Therefore, we deduce that this is D vector, -2, 4, 3. We put equation of a straight line as form R vector equals A vector plus TD vector. Therefore, R vector 3, -1, 0 plus T, -2, 4, 3. This is vector form of equation of straight line. Remember, my dear student, from this equation we can find parametric equation of a straight line, but in this case the required vector equation. When the required parametric, we replace R vector by x, y, z. Therefore, x equals 3 minus 2t. Y equals -1 plus 4t. Z equal 3t. After that, we can find the Cartesian equation of a straight line by x minus 3 over -2, y plus 1 over 4, z over 3. Then we can find all forms of equation of a straight line by using point and direction vector. If we have point and direction vector, we form any equation of a straight line. T is a real number, doesn't express unique constant number. It takes different real values and is called parametric, and for each value this parametric T. We can find a point on a straight line. My dear student, now we are translate to another example. Prove that two straight lines are 1, 3i plus j minus k plus t, 1i plus 2j plus 3k, and r2, 2i plus 5j plus t2, I negative j plus k are intersecting. Then find equation of plane contains them. My dear student, the position of two straight line may be parallel, may be intersect, may be skew. We have three positions of two straight lines. Number one, two straight lines are parallel when d1 equals d2 or d1 equal k d2. Number two, when two straight lines are perpendicular, then d1 dot d2 equals 0. What you mean d1 dot d2 equals 0? Product or scalar product of two directions d1 and d2 must be equal 0, then the angle between them equals 90 degrees, or two straight lines are perpendicular. After that, if straight lines not parallel, not perpendicular, then we have other straight position of straight line are skew. Two straight lines are skew when lies in two different planes. Look at, my dear student, if the two straight lines are intersect, we put R1 equals R2. We put the equation of R1 and equation of R2. Remember, two straight lines, we suppose or let the two straight lines intersect, then R1 equals R2. What you mean? By equation of coefficients of two lines, then we deduce that the first equation T1 minus T2 equals negative 1. After that, second equation, when 1 plus 2T1 equal 5 minus 2 T2, therefore we deduce 2T1 plus T2 equals 4. Then we have two equations in two unknown, T1 and T2. Therefore, we put T1 negative 1 plus 3T1 equals T2. Therefore, 3T1 minus T2 equals 1. This equation number 3. By solve equation 1 and 2 by any method. We have two methods, omitting method or substitution method. We deduce that T1 equals 1 and T2 equals 2 from equation 1 and 2. When substitution about T1 equals 1, T2 equals 2 in equation 3. Look at, we find that it satisfies the equation, then the two straight lines are intersect. My dear student, now we are translate to another title, equation of the plane in space. At the first, what is the plane? Plane is a straight line extension in more directions. We know that plane. We form a plane by using two straight lines are parallel, two straight lines are intersect, straight line and point doesn't belong to it, or any three non-collinear points. Look at, my dear student, if the point A, x1, y1, z1 belongs to the plane. Point A, x1, y1, z1 belongs to the plane. Position vector of A and the normal direction vector n, A, B, C, and the point B, x, y, z, any point on the plane, its position vector is R vector. Then n dot AB or scalar product of AB equals 0. Why? Because perpendicular, we know that from the solid geometry, when two vectors are perpendicular, then the first dot or scalar product, the second must be equal 0. Therefore, what is the AB vector? B minus A. Then n dot bracket contains B minus A equals 0. B equals R vector. B vector equal R vector. Then we deduce that n dot R equals n dot A. This equation of plane. The vector form of equation of plane n dot R equals n dot A. N normal vector. R this x, y, z, coordinates x, y, z, but A vector point A belongs to the plane. To find the vector equation of the plane, we must know a point on the plane and perpendicular vector to the plane or n. Example. Find the vector form of equation of the plane has normal vector n I plus j plus k. What you mean? 1, 1, 1. Components of the n 1, 1, 1. And contains point 0, 1, 1. Then if we the required the equation or vector form of equation of the plane, we must know n and the point. Look at the solution. The vector equation n dot r equals n dot a. By substitution about a 0, 1, 1 and n 1, 1, 1 by substitution, then we deduce that equation of plane 1, 1, 1 dot r equals 2. Standard form and general form of equation of the plane in space. What do you mean, or what is the difference between standard form and general form of equation of the plane? N dot r minus a equals 0. This is called standard. N a b c but r x y z. A vector x1 y1 z1. Therefore, we deduce that the standard a b c dot x minus x1 y minus y1 z minus z1 equals 0. Therefore, a multiply x minus x1 plus b multiply y minus y1 plus c multiply z minus z1 equals 0. This is called standard form of equation of a straight line. By expansion, we deduce that ax plus by plus cz plus bracket contains negative ax1 negative by1 negative cz1 equals 0. We consuming or put d equals ax negative ax1 negative by1 negative cz1, then we deduce ax1 negative by1 negative cz1 equals d. Therefore, ax plus by plus cz plus d equals 0. This general form of equation of the plane. My dear student, look at the important example. Find standard form and general form of equation of plane passing through the point 3, negative 5, 2 and the vector n 2, 1, 1 is normal to the plane. Solution. The standard form is form A multiply x minus x1 plus b multiply b minus y1 plus c multiply z minus z1 equals 0 by using substitution about a, b, c and x1, y1, z1. We deduce that, my dear student, standard form 2 multiply x minus 3 plus y plus 5 inside bracket plus z minus 2 inside bracket equals 0. But general, by expansion, 2x minus 6 plus y plus 5 plus z minus 2 equals 0. This expansion and to collect the like terms, we deduce that 2x plus y plus z minus 3 equals 0. This equation of plane, but the first is called standard, but the second is called general. Then we deduce that general equation find from the standard form of equation of the plane. Don't forget, my dear student, this difference between standard form of the plane and general form of equation of the plane. Standard form, A multiply x minus x1 plus B multiply y minus y1 plus C multiply z minus z1 equals 0. But the general equation ax plus by plus cz plus d equals 0. This equation of the plane. My dear student, by the end of this lesson, we know that the difference between general form and standard form of equation of the plane. Don't forget, my dear student, equation of a straight line and equation of the plane, very important lesson. To find the equation of a straight line, we have three types of equation. As the first, vector equation, parametric equation, and Cartesian equation. But in the plane, we have two types of equation of the plane. The first is called standard and the second is called general. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.